All right, let's see what we got here. A little off timing, but better late than never. Delete columns to make sorted part 2 medium. You're given an array of n strings, all of the same length. We may choose any deletion indices, and we delete all the characters in those indices for each string. Okay. So here the strings are both 6 length. So choose any deletion indices. So deletion indices are 0, 2, 3, so we delete it and we get B, F, B, Y, Z. Suppose we choose a set of deletion indices answer such that after the deletions, the final array has elements in lexicographical order. Return the minimum possible value of answer length. The minimum possible value. After deletions, the final array has elements. Minimum possible value. Answer length. Alright, I guess I need to look at an example. CABBAC. Output is 1. After deleting the first column, it's ABC. So strings is in lexicographical order. We require at least one deletion since initial strings was non-lexicographical order, so the answer is 1. So is the return the length is the number of deletions. Minimum possible value of answer dot length. Suppose we choose a set of deletion indices. Okay, so this is the answer. I see. XC, YB, ZA, this is all in lexicographic order. So you need to delete nothing. Here, I see. So if it's impossible, basically you delete all the characters and get, okay. Interesting. Okay, so how would I go about doing this? I think this might be CABBAC. I wonder if converting the characters into just numbers, so like C converts to like 3 or 2, A converts to 1 or 0, and then just doing some sort of deletion of the array of indices, array of integer equivalents for the characters, so you're gonna have to worry about characters. And then use comparing integers maybe. I'm not sure if that's any faster. Maybe. Lexicographical order. What is this? The lexicographic or lexicographical? I guess lexicographic is an adjective, right? But then what's lexicographical? Is that an adverb? Is that adverb? Lexicographical is an adjective. Lexicographic. Okay, lexicographic and lexicographical are actually the same. How odd. Graphical, graphic. Okay, anyways. Deletions. So for the first example, we see that C and B are in the first index, so they have to be deleted. Otherwise, it's not possible, right? So delete it, and then A, B, C. So X, Y, Z are all okay. I think this might be a greedy approach, so you just start deleting stuff. That doesn't work. Then if you delete it, then you have to reset to like comparing the next thing. Interesting. So like if it was something where the deletion, so let's say you have A, you have B, and you have A, C here. So A compares to B, that's fine. And then B compares to A here. And so you realize that you can't do that. So then you have to restart to the front. So then maybe it goes something like D, B. So now you can delete the second thing. So you have to reset to the front each time. Is there a better way of doing that? So you find, so for some, so as you go through the words, you're going to start with index 0, and if you find that index 0 doesn't work, then you have to go back to the starting word and then compare index 1. That's going to be n squared almost assuredly. You're making it pass through every word or string and then making it pass through every index within it. I mean, that seems actually doable here. It's just 100 by 100. Although comparing, I guess maybe that's not right, because if you compare the same character, you have two characters that are the same value, like A to A or B to B, then you have to then compare the next index. At that point, those might be tied, and then you have to compare. So maybe it's like n cubed, really. N cubed. They had, so let's see if you convert this into just numbers for the letters. So like 1, 2, let's say this is 1, 2, 3, and this is 1, 2, 2. Then you would need to compare 1 to 1, and then 2 to 2, then 3 to 2 to 3. Doesn't seem particularly good. So it has to be it has to be 1 compares to 1. Working with the ties is really rough. Ties just don't work very well. It's not easy to compare. Okay, I think I'm gonna first just for my sanity, I'm gonna convert these into convert a string H string to array of ordinal values, basically, i.e. or e.g. ABC becomes 0, 1, 2. So let's say array, and then for every string, I'll call it a word. In strings, let's say conversion is a list comprehension from ordinal of the letter minus ordinal of A. Ordinal of the letter minus the offset for every letter in strings. Then I'll just go ahead and put that into the array. And I'll verify that this works. Oh boy. Is this wrong? Ordinal of a letter for every letter in strings for every letter in the word, not in strings. 201102. Okay, that's fine. Okay. X, Y, Z. Easy as A, B, C. C, A, B, B, A, C. So you compare C to B. Find out that doesn't work. And then compare A to B. If there's ties, then it has to break a tie. I wonder. I feel like there should be some way for me to do some. Can I roll? Can I somehow convert numbers in multiple spots into a single number? Like if it's 1, 2, convert it to 12. 1, 2, 2, convert to 122. Not sure if that's. I mean, interesting. 26. Huh. Huh. There's no way that works. So string is 100 and there's 100. So I mean, at the worst case, there would be 100 values associated with each string. The 100 values would be based on the sum of everything. So if you have a string that is like 1, 2, 3, then the 100 value, so this is 3 values. So it's either 123, 23, or 3 as the basis comparison. You're comparing just the first, if you don't do any deletions, it's 123. If you do deletion of the first index, then it's 23. Second index and first index is 3. So at worst case, there's 100 values associated with this one array, one word, if it's of length 100, and then there'd be 100 times 100, right? 100 times 100, 10,000. Ooh. I'm pretty sure what I'm thinking is not very fast. So if I do the conversion of every string to every possible value based on the number, the deletions don't have to be in order, does it? Right. Deletions could be in any order. Oh my god. Oh my lord. Deletions can be any order. Eeks, 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 eeks. What does this mean? I mean, is it true? Okay. Interesting. So what I'm picturing in my head right now is a connection of increases. A connection of increases. So for instance, if this was ABB, right? For the first character ABB, then if that doesn't, ABB by itself works on the first level, and then on the second level, if it doesn't work, then it needs to delete characters until it works. Interesting. So what's going on is, so I think the algorithm would be, you consider the first index, you consider how far the first index goes in terms of being correct. Yeah, being correct in terms of everything of that first character has to be tied or higher. Yeah, everything on at that character has to be tied or higher, right? Like A, B, C here can't be C, B, A. X, Y, Z can't be C, B, A. It could be AU, it could be BV, it could be C. So this thing can work for every single starting letter. Actually, you don't have to delete anything here. So if it works for every single starting letter in that index, or if you go through whole array at that index and everything is equal to or tied, so it's not decreasing, but it's so it's non-decreasing, but could be tied or ascending at that index. Technically that works completely if there's no ties. If there are ties, then you need to delete until you find an index where in the portions that they're tied that it's increasing. In the portions that they're tied, it's increasing. Or it has to be non-decreasing. It has to be non-decreasing. And then again, if there are ties there, I guess it's just in the first tie that you encounter within that, you delete until you find the first index after that that is non-decreasing those, and then repeat. I think that might be roughly correct. So you do have to find an index that works for it to be non-decreasing at that index initially. Okay, so let's go something like this. Might be like an inner loop. So assuming that let's go full. For every index in the range of let's say the word length, the word n. And it's going to be the length of strings at 0 for every, and let's say num words is going to be the length of strings. So for every index in range word length, no, I guess am I iterating through the indices, or am I iterating through? I think I'm iterating through the indices. Okay, for everything in the range of word length. So I'm going to see if this index works. I'm going to see if this index works. I think I want to tie Boolean. And then for every word index, I'll call it index, in the range of the number of words. Maybe number of words minus 1. So I think I might be comparing the word at this index versus the word at the next index. If the value of the word at this index at this index, I guess maybe I'll call this the letter index, the lindex. So sorry, this is going to be strings at this word index, at this letter index. Actually, I should be the array, right? It might be okay to use the strings, but whatever. array at this word index at this letter index is less than or equal to, or if it's greater than, then I need a break, because then it just doesn't work. No, it's going to be word index plus 1, letter index. There needs to be some sort of break here. So I think this should be like fail. Fail equals false. Fail equals true. Else if the array at this index, word index, at this letter index is equal to the array at word index plus 1, the following word, at this index, at this letter, if it matches the ties, can be true. I need basically somehow keep track of ties. And then otherwise it's less than, and if it's a less than letter or value, then it's fine. So a couple things here. One is I need an array of indices that I'm actually caring about, I think. So for instance, let's say something I'm dealing with values for it being like 1, 1. Okay, let's say it's 1, 2, 2. So here's is technically fine, but 2 is tied with 2. So if there are more indices, then I would need to have something that is not descending in the second character for these particular indices. So if it was like 5, 4, 3 here, that doesn't work because 4 is going to be bigger than 3. 5 doesn't matter. Like 5 could be 1, 5 could be 9. It doesn't matter. It's the tie is working in these two. And technically it should be, then it could be decreasing here, or it could be bigger here than these two. But these two needs to have a tiebreaker until later indice. And if there's tied in that indice, then they need to tie break again. What happens? Yeah. So if it was like, let's say there was another 2 here. Let's say it was like 2. Yeah, let's say it was 2, 2, 2, 3. Or 2, 2, 2, 4, 2, 4. Then I need to break the tie in 4. If it was like 2, 4, 2, 3, 2, 4, then it wouldn't work because 4 is going to be bigger than 3. So I would need to go to, it'd be a fail. I would need to go to another index to try to go through these. So I think maybe I need to have some sort of array of indices that I'm concerned with, where the array of indices is all indices of the word length. Yeah, so I wonder if that should be like a stack, really? Queue, maybe? So I'm going through all the indices. I'll call these the active indices, and it's going to be 0. It's going to be list in the range of word length, I want to say. That's right. So 0, 1 is active. 0, 1, 0, 1, 2. Okay. So I'm going to try find indices that are strictly non-decreasing for the active indices. So for every indices that must be non-descending. Actually, maybe this should be words that are non-descending, right? These are words. Indices of the words that must be non-descending. Yeah. So originally it's going to be everything needs to be non-descending. Everything must be non-descending. Okay, I think I need an answer array. And I'm going to go through every letter index and see if by deleting this letter, the active stuff, see if I need to delete this letter, basically. Yeah, see if I need to delete this letter. So for this particular letter index, so I go through 1, 2, 2, 4, 1, 1, 2, 2, 2. It's the stuff at this letter. Do, 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 do. Do, 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 do. For every So confusing. You go through this letter for every word in the active list. So it's not the number. I guess I need to have a num active currently. Then we have the next active set. So for every word index in the range of num active minus 1, if the active gives me the index I'm dealing with. So active so what's going on here? So it's like the active indices are 0, 1, 2, 3, 4. 0, 1, 2, 0, 1, 2, 3. So I need to compare 0 with 1. The word at 0 with the word at 1. So it's going to be something like if the array, the index is actually I'm going to go ahead and just say this is so if the array at active at I, that gives me the array of offsets at this letter index is greater than the array at active at I plus 1 at this letter index, then this is a fail. So I need to skip this. I guess I'm deleting it in order. So maybe answer is just counter. So I need a break here. And then if this is a fail, then just continue. So I need to go deal with the same active indices and use the next letter index as the thing I want to delete from. Yeah, I think that logically makes sense. Else, if maybe I should just do yuck. I guess maybe this should probably be current. Current is active array at, or let's say previous. Actually, previous is equal to array active at I, active at 0 at the letter index. I guess the letter index is, yeah, that's fine. And the current is going to be something here. Array at active at I at the letter index. This needs to iterate from 1 to num active And at some point I need to say that the previous equals current. I just don't want to get these references a lot. Yeah, okay, so if the previous is bigger than the current, this is a fail. Else if the previous equals the current, then the next active needs to take into account this. Next active dot append hmm, 3, 3, 4, 4. Okay. What's going on here? Okay, if I were to have something where it's 1, 1, 1, 2, 2, so in theory, 1 needs to be tie broken. But then, what does this mean about the 2? Like if it's 1, 1, 1, 1, 1, 2, 2, and I say 1, 1, 1, 1 is the second character. In theory that works. But technically it's still tied with the 1 and 1 and kind of with the 2 and 2. It's tied with the 1 1 and the 2 2. Maybe I should be just using a stack here. Maybe I should be just using like a monotonic stack. Monotonic stack, does that work? Really? 1, 1, 2, 2. Stack the 1, I can stack the 1, stack the 2, stack the 2. If I do 1, 1, then the tie needs to break the 1, 1. Then it can't also be backwards. Okay, the tie needs to break the 1, 1. But if the tie breaks the 1, 1, let's say it breaks it in like 3, 2, no, sorry, 2, 3, 4, 3. It doesn't quite work because the tie needs to break the 1, 1, and then something needs to break the 2, 2. Otherwise I can't keep the first index. So should I can see a way where it deletes. Are they all tied? 1, 1, 2, 2. All the places where it ties. All the places where it ties. I think I need to find a later index where it doesn't tie in those places. So if there's any tie, if there's any tie, then I need to anything that I keep after this needs to break that tie there. So even though it's 1, 1, and the 1 and the 2 here are not tied, it's still part of the next active thing that I need to go through, the next active set of indices, because the 2 is tied with this 2. So whatever happens here needs to be increasing. So how to do that? So if the previous and the current are tied, then I'll append both. I'll append the previous if the previous doesn't equal the last thing that's already appended. So if previous doesn't equal the last thing in the next active, next active appends previous. Now it's supposed to be indices. Active, so if I minus 1 and next active appends I. Otherwise it's increasing, so it doesn't need to append either. And then previous equals current. And then fail. This might be tabbed incorrectly. No. If it fails, then move on to the next index. If it doesn't fail, then active should equal the next active. And then I need to return the answer. This probably definitely crashes. Yeah. 21. Active at 0. Okay, yeah, this needs to break if the length of active is equal to 0, break. No, sorry, the length of next active. Oh my god. Okay, I definitely just want to try some test cases to make sure this is working on the harder ones. So if it's tied at the very first one, let's say it's A, B, B, and let's say it's tied here, let's say it's X, Y, and K, P, Actually, this is gonna fail. Yeah, technically it just needs to delete. Let's delete 0 here, I think. But then it's gonna say that it's delete 1, maybe. Yeah, this one do it wrong. Oh, it's not gonna even do it all. If next active. No way. There's no shot that this did it right. 0. What? What's going on here? There's just no shot. It should be doing it well. Let's see, index. EX, AY, BK, BP. 0, 1. Leetcode. The factor starts empty. If there's a tie with the last one, oh, this should be OR. If it's so, if there's, if it's, if there, no, this should be AND. What's going on here is 1, I equals 1. Num active should be 4. Array at 1. So I should be comparing 0 to 0. If the previous is bigger than the current, then this should fail. Okay. If the previous equals the current, like A equals A, then should add both these indices into it. Oh, should be appending I minus 1 here. Should be failing this one. What the hell? If I minus 1 is already part of I minus 1 not active, append, at index, the letter index 0, it only has 1. Alright, I think we'll look at the array, I guess. Zero, 23, 24, 110, 115. Okay, go ahead and print here, print I previous current. Okay, index 1 is comparing 0, 0. They're tied. So the previous is equal to the current. previous equals the current, and it's handling the tie. Handling the tie if next active. Oh my god. No, if next active, so if there is something in the next active and I minus 1, which is 0, doesn't equal I guess it should be if next active, if not next active, or okay, so somehow still handling it correctly even though so 0, 1 gets in there. But then 1 and 1 needs to get in there as well. So like 2 and 3 needs to be added to here. I'm not sure why it doesn't. So index is 0, and then index is 1. And then active is going to be oh, I see. It should be a range of numwords. Yeah. Alright, finally. Okay. So 0, 1, 2, 3. Okay, so this thing needs to be strictly increasing. So in theory this works in terms of like x is small than y, ax, ay is fine, bk is smaller than bp. So I wonder. Ax is smaller than ay. So active interesting. So technically this is a tie, and what does that imply? It implies it needs to be increasing or non-decreasing here in the next version, and then almost separately it needs to be non-decreasing here. Like, it doesn't matter if this is strictly going down here. It just has to be non-decreasing there and non-decreasing there. Oh boy. AX, AY, BK. Man, I wonder if I can somehow fit in some sort of monotonic stack here. Push the A into the stack, push the A into the stack, push the B, push the B, push, 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 push. Somehow you're working your way until it actually is empty stack. A. So the A's separate it from the B's, such that eventually the A's need to find something that's not decreasing, and the B's need to find something that's not decreasing. A, B, B. It's like you need to find something that is, there's some value. The next value needs to be non-decreasing, 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 non-decreasing. And then the next iteration needs to be some value non-decreasing. This can be anything. And this needs to be non-decreasing. That's rough. That wrinkle is rough. Some value non-decreasing. Decrease. So if you add to a stack all the values in a particular index, all the values of a particular index, AX, AY, KP. The A's are tied, so it has to be a non-decreasing sequence where tie goes to the next value. BKP non-decreasing, tie goes to the next value. What happens if I have push 0, push 0, push 1, push 1, push 0, push 0, push 1, push 1. And if it doesn't work, then I need to reset all the way to the front. Zero, be the index as well. 0, 0, 1, 0. Does the index matter? 0, 1, 1, 2, 1, 3. So this is letter value index. So it needs to break ties. So there's still stuff that are tied. It needs to break those ties. If there's something like, let's say the test case was, let's say there's an intermediate value here. Okay, let's say it's B, A, CK, and CP. So yeah, the 0, 0, and the 2, 2 needs to be taken care of in a later index. But the 1, 0 here is kind of fine because it's strictly not tied. It's already smaller than the next one and bigger than the previous one regardless of whatever is the following indices. So maybe something like that makes this into something like that. 0, 0, 0, 1, 2, 3, 2, 4. And the 1, 1 that's here is, or the 1, 2 that's here is ignored. So in the next iteration, it needs to go through these. It needs to see that whatever happens here, 0, 0, because it's tied here, then it needs to be strictly non-decreasing in the next one. And if it's if it's not tied, then it could be anything. If it's not tied, it can be anything. But if it is tied at this index, like, yeah, so it's, so I need to deal with an array of indices and the value of those indices of the previous layer. So maybe the starting layer is actually, the active is actually a list of tuples. Active equals list. I guess I'll just do a list comprehension here. It's going to be I0 for every I in range of numbers. So everything's tied for all the indices. So this is the index and the value at the index. Okay. Does this make sense? Oh my god, it's so complicated. Index value for every letter index in the word range and the word length. Yeah. And then fail is false. Num-active is the number of actives. Next active is the next active. Previous is going to be active at 0. The value, right? So I'll use this. Right, active 0. be 1 right here. No. So the previous the index is part 0, active at 0, 0. Array active at 0, 0. Current one is active at I, 0. The letter index. Okay. So here I need to compare it based on the previous layers. Okay. I think I need to do previous index and previous value maybe. That makes sense. Active is a tuple. I don't know. I think it should be previous. Yeah, I'm confused. I'm confusing myself. Previous is the previous value within the current layer. Current is current value in the current layer. And we'll say sub value is the array. Is it just active at 0 at 1? First thing in the active is the index I'm using. Second thing is the value that I need to compare. So this is going to be this previous sub value, and this current sub value is going to be active at I at 1. Need to also do previous sub value is now equal to the current sub value. Okay, so technically this only needs to occur if the previous sub value is, if it fails, if the previous sub value is equal to the current sub value. Yeah. If previous sub value is equal to the current sub value. Because that means there's a tie, and this needs to not be, if there's a tie in the previous sub value, then this is going to be making it not in correct order at this layer, at this index. And then else what? So here I'm assuming that if the previous sub value equals current sub value. Yeah, I guess maybe I can just say if they're not, if the previous sub value is already bigger than the current sub value, is already, yeah, I think maybe I can just skip this check here. Previous sub value is not equal to the current sub value. And they're probably going to be, then I just need to skip this. I don't need to worry about it. I can't skip this. I need to actually do this portion. So, okay, so I think this should be like this. Okay. So they're not equal, so I need to tie break here. So tie break in this current layer. If the tie break doesn't work, then it fails. Break. Otherwise, if the tie break is the same in this layer, then I'm going to, in the next active, add this index. See if it's empty or the previous ones. I minus 1. I think this is correct logic here. If not, if it's empty, then we need to add this. And the add here should be next active append tuple, that is the last index and the previous value. Otherwise, or additionally, next active appends the tuple, that is I and the current value. There should be an OR here. If not, next active OR. So if it's empty, then add both. If it's not, if it's empty, add the previous one, or add the previous one if the last index doesn't match this index. The index or last value, I guess it would probably be the same. Okay. Oh God, I think that might be right. Yeah. Okay, so somehow I got that one. 0. This should be 1. Oh. We get 0 here. So the rate's 2010 or 201102. So I should be comparing the 210. Alright, let's go ahead and put this active. So it should give me, I'm going to say 001020. Okay, those are the indices basically tied. So in which everything needs to be broken, tie broken. So the index fail plus false non-active is the length of the active indexes. Next active is that, sure. Previous and sub. Let's go ahead and say print start and index previous and the previous sub value. So here the starting index is going to be 0, which is the index of the letter to be considered to be deleted. 2 and 0. 2 and 0 is the previous and current sub value. So 2, 0 is just 2 and 0. So, okay, it skips it with the previous not equal to the current sub value. So if it equals the current sub value, then it's a tie and it should. If it's tied, then it needs to actually do this. I think this might be backwards. If the previous equals the current sub value, then you need to do it. Oh Lord. I don't feel good about this. But let's see how it goes in the broader test cases. Standard out. There's still another printout. Oh, schmuck. Well, I mean, that's a fair amount of test cases. 100. Oh my god. Oh my god. Alright, so let's go ahead and so consider here 24, 22. So what is the word length here? Did I add this to the test cases? I did. Word length here is 30. Okay. So I'm deleting too much. I'm deleting too much. I said I need 24, but here I can only delete 22, 30. Okay, so if I have some active, everything's active, current sub value, active at I at part 1, with the previous sub value equals the current sub value. So if it's tied at the previous layer, then you need to find something that's not decreasing. But if it's not tied, then you don't care. The previous is tied and the current is tied. previous is tied and the current is tied, then the next layer needs to break it. Yeah. Next layer needs to break it. Needs to break this particular index. This particular index has I minus 1 previous and I current. If the length of the next active is 0, what if the length of the next active is 1? I guess it should be if the length of the next active is less than or equal to 1. Still incorrect. Still fails, deletes. It says deleting too much. It's deleting too much. Oh, okay. So I'm just going to print the word length and the number of words I'm dealing with there. How many words is this? 30 words of length 30. Okay. So active is all the indices, they're all tied. Fail is false. That is false. Only really add if there's a tie at the previous layer and a tie at the current layer. Tie at the previous layer. Tie at the previous layer and the current layer is worse than this, just fail. There's a tie at the previous layer and it's strictly better at the current layer than I have to worry about it. And when we do worry about it, there's a tie at the current layer. Then what? Then you need to add both. Add both. I don't know if this is strictly better if I did something like hmm. not active. If there's empty or the previous thing within the next active is the same as the current thing. Or it's not the same thing as the current thing. I must be previous, I must I current. Previous subvalue, current subvalue. Okay. Yeah. Man, if only there was a slightly easier thing to parse. This is simply it's a little complex for me to figure out. So delete 24. So I wonder. Actually, so skips. Let's go ahead and say answers an array. If I want to skip it, it's going to be an answer append this I. This letter index. And then my return is just going to be fail continue. I guess my answer is going to be the length of the words here, word length, minus the length of answer. Oh, my math is so bad. What is it? Is it just the length of answer? Yeah, just the length of answer. Okay, so here are the things I thought I need to delete. So pretty much every letter except 23 through the end, the 23rd letter and on. That's going to be hard to decipher. Expected is going to be 22. Huh. So that means there was some prior letter that could have worked. There was some prior letter that could have worked. Previous subvalue equals current subvalue. I see. I think I see. So if it was something like this, AX, AX, I think that might fail. Didn't fail. So okay, so maybe if there's something like that, AX, AX, CX, CP. I don't know if this fails the code, but I think this is the premise of why it's wrong. So what's going to happen here is it looks at these two and they're tied. Looks at the A and A is tied. So then it's going to do X, X, but only the X-axis. Only the X-axis stored. And then it looks at the CX and CP, and only the X and the P are stored. So it needs to actually differentiate between this X and this X, because this X doesn't mean that this is tied. It doesn't mean that these two are tied. I think I just need a incremental value to denote when ties occur and when ties don't occur. Yeah, to denote when ties occurs and when ties don't occur. I think maybe this should be like something like a tie value. So if previous subvalue equals current subvalue, previous subvalue equals current subvalue, then it needs to break. So it needs to be something like, almost certainly needs to be something like tie value. There's a tie between those two values. Previous equals current. Then we're still using the same tie value. Maybe else tie value increases. So if we're dealing with the same subvalue, then we deal with the same tie value. If we're dealing with different subvalues, then the tie value should increase. Okay. This is to say that there is some differentiator, so I think maybe this needs to compare tie values. So I minus 1, so I think maybe, or if tie value doesn't equal the previous tie value, but 29. Okay, that's going in the wrong direction. Huh. Previous subvalue equals this same subvalue. Previous subvalue. I think I should probably figure out a test case that I could look at, like AX. Let's say if these two are, say, A, now let's say B, 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 A. Okay. So it should be deleting just one. Let's say that I need to delete two, or my code is telling to delete two, both index 1 and 2, and leaving with A, B, C, C. But it should just delete index 1 and move it to A, B, B, A, C, A, C, A. Okay, so let's go ahead and see what's happening here. So I guess before actually maybe at the start of the loop, I'll print out the actives. And print at the start of loop 1, everything's active, index 1 to 0 to 4. And then here, A is tied with A, C is tied with C, so it should be 0, 0, or 0, 1, 3, 4. Okay, that's not right. There should be 3 right here. 0, 0, 1, 3, 4. 0, 1, 3, 4. Because C is equal to C here. So just can't ignore that. So why does it skip it? Previous equals, right? So the previous is equal to the current, because it's 0 compared to 0 at that point. Previous sub value equals current sub value, and previous equals current. Okay. Okay, so handling tie for 0 versus 1, handling tie for 3 versus 4. So it's handling tie. Okay, I see. I think I see. If not, next active. Yeah. So I think this should be the tie value. Tie value isn't the last tie value that was added. I minus 1. I'm not screwing up my eyes. I in the range of I is just wrong, isn't it? I think there should be highest value within the active array. This is seriously wrong if that's the case. Yeah, seriously wrong then. There should be like active at I at 0, active at I, active at I at 1, and active I at I minus 1. Active at I at 0, that index, and no, active at I minus 1 at 0, active at I minus I 0. Wow, that'd be a pretty big change though. Somehow the other ones worked. Still not correct though. 0, 1, 4. The tie value doesn't equal the previous inserted tie value. Previous sub value equals the current sub value for the same. Then keep on using this tie value. They're different, then increase the tie value. Do this current, then the tie value. Okay, so how is this ending the tie? It's not doing insert. I guess I need to know maybe what is the next active at that point. Okay, so that's fine. The next active is that. So I know tie value. This tie value should be like 2 at this point. Tie value is still 0. It doesn't seem like what I wanted. Tie value should have increased. Previous sub value. I see, yeah, okay. Previous sub value equals current sub value. I think there should be an else here. Yeah, it's no longer tied if the current values are increasing correctly. Still still not increasing. If previous if is equal, which it is, they're always equal. If the previous is bigger, then it's not going to work. Current is a tie, then it's going to use it. Otherwise, this really should be like a 2 here. Those are the previous, I, previous, current. I, previous, and current. Your tie value doesn't change at all, still 0. Oh, fuck me, I'm initializing tie value 0 here. So stupid. Yeah. No, was this necessary then? I think it was. Yeah. Wow. This errors abound. Just randomly fix an error and find more errors that I didn't know about. Okay, so worked on the harder two. Is there more prints? There was one more print. Oh my god. Holy shit, this is 3 hours. Okay. I'll take it. Felt pretty bad. This code is just a mess. I'm pretty sure I can go without using indices, using a for each loop here. And go back to, I guess the answer array is fine. Yeah, I don't think I needed to convert. I think everything here would have worked. I think everything here would have worked if I just used the original thing. So I want to do that. I want to get rid of this array. So array is the same thing as strings. Array to strings. That's only 2 places, right? And if I put this, this is probably still correct. Wonder if that changed my speed at all. Probably not. Yeah, slightly improving. Okay. Words active. Guess this is not a value, but tiebreak value. Just a note when there's tiebreak that needs to occur. The 0 means everything needs to be a tiebreak on the next level. A tiebreak value matches between consecutive tuples. Consecutive tuples must tie break in a subsequent, I think of it as layer, which is basically index, letter index. So every letter index fail is going to be false initially. Number of active things to tie break. The next active things to tie break. Here I think this should be done with a for each loop, to be honest. Can I do this with a for each loop? I think that might be just too much fixing, if I can call it fixing. Tie value. Current value of this layer. Current previous. I think I could call this tie value. So if the previous tie value and current tie value are the same, and previous tie value and current tie value are the same, so maybe I can do an OR here, or maybe I can do an AND. If previous tie value and current tie value are the same, and maybe it should be not the same. What's the logic here? If previous tie value not equal to current tie value, or the previous value is bigger, or the current value is bigger than the previous value less than current value, tie value increments. Else if the previous is bigger than the current. So this means that the tie value is the same, the previous is bigger than current, and this is a fail. Break. And then just the last else. The only thing here is the previous matches the current. Okay, that was a lot of changes. Hopefully this logic is still correct. Else if else if previous is greater than current. So values change the tie value. Actually, maybe I can do this slightly more concise. Previous and previous tie value. Current and current tie value. Okay. Logic is a little tidier. Still not great. Indices, tab. Okay, this is fine though. Sweet, sweet. Non-significant difference between my solution and probably a lot better solutions. All right. So the summary here is formulated an array of tuples that were basically indices, index, and tie-break value, whereby only the index in those tuples, only the indices in those tuples needed to be in lexicographic order. The starting array for that is 0, 0, 1, 0, dot, 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 n minus 1, 0. Which indicates that all indices are to be considered, and they are currently tied. So if you look at an example for, let's say, the array is AX, AX, CX, and CY. This would translate to a secondary. Okay, so even though index 1 is, or index 0 is without later consideration, is in lexicographic order, i.e. A is less than A, or less than equal to A, less than equal to C, less than equal to C, less than equal to C. There are some ties that need to be broken, primarily between the A's and the C's. Like technically, this A needs to be broken with a tie break, and the second thing where anything after this A needs to be better than this A, and anything after this C needs to be better than this C. This translates into the array into the next version of the array. That is something like index 0, tiebreak value 0, index 1, tiebreak value 0, index 2, tiebreak value is 1, index 2, tiebreak value is 1. Or sorry, index 3, tiebreak value is 1. Tiebreak value helps to identify which indices needs to be different or kind of bigger than a previous index. Like even though here A is next to X and C is next to X, they have different tiebreak values because the A is always smaller than C. So therefore this X doesn't really isn't equivalent to this X because it doesn't need to actually be tie-broken. So only tuples with values with same tie-break values need to be tie-broken in the next layer index. So yeah, that's pretty much this logic here. You have an active list of tuples, and you're iterating through indices to see if the indices work to break that list. And if it partially works, in the sense that if there's still ties within that layer, then it creates the next layer of active tuples based on the logic of when something is an improvement or something is a bigger value than the previous layer. So keep track of active tuples, iterate over indices to see if that index works to fully order the actives. If there are ties within that layer, keep a list of new tie breaks. If it doesn't work, basically orders non-orders descending. Restart at a later index with same active tuples, and then return or change if finished with all tuples, convert next active list of tuples to current active list of tuples. Return afterwards. Count of number of deletions. Right. So yeah, this logic was just fucking long. Time complexity is going to be O of. I think this might be O of n squared. Is that right? Yeah, it's O of squared. Since for each index, it's possible to go to the very end before determining that it doesn't work and restarting at the front of the active list. So like in the worst case, it could be like the first index is like z, 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 and then y, and then the next, so that deletes the first index, and then you go to the next index, and it's all z's, and then y, so that only at the very end do you recognize that you need to delete that index from consideration. And so that'd be the number of words times the number of letters in which word, which is both n. So let's say this can be O of n to keep the list of active tuples, which is at most n tuples. Alright, well, that was a chore.